think I'm done. Yeah, I think I'm done with that. Back to the housing. So this assembly, this now this is well, not it's not totally ready for a print yet because I just need to address the drive dimensions here. So let's go back to the let's go back to this assembly where they're together. And I need to bring in like I just got to finish out this end like that. So I'm going to bring in the bearing, the other bearing model that I have, and I'm going to place it in here. Oh yeah, it's pretty early on in my process here. Yeah, I have my two bearings. They're just that's the one I want. The big tapered roller ball bearing here that'll accept thrust. Bigger bearing assembly. I think it's spherical, or I can't remember what the rollers are, but they might be cylindrical bearings on this one. The other one's like round ball bearings, like you might think of a normal bearing. This one is actually like maybe, yeah, maybe they're a little bit more cylindrical actually roller, and they're kind of in a cage system. Anyway, it's kind of interesting bearing. I'm going to place this one in though. And I could use my insert on this too, because I could say, oh, insert this to the housing edge here and a ½ inch offset in that insert. And then I'll have to use an insert and a plane alignment. So I think I'll do that. It'll be the day of insert constraints. I'm just looking to insert on what, something on the outermost face here. Oh yeah, this is the other bearing that I have for McMaster car. So I early on, I mean like within the first week or whatever working on this, we pulled these two bearings for McMaster car. This is the first one we had, smaller. This is the bigger one, thicker this way. The whole bearing assembly is different in here. And it's like 4 times the cost of this bearing versus the other one. But so what I'm looking for is just like an insert constraint on really any edge profile that's the outermost, like from the bearing area. I think these surfaces line up like, well, I can't say that for sure. Um, so maybe, actually, let me check that real quick. Or otherwise, I can't use an insert. I just want to know, is this surface, this is what's going to be up against the seal plate. And is this surface to this surface the same? They're actually 1/8 of an inch different, which I can calculate that in. It's just that the little feet on it are a little bit, they protrude past the outermost part of the bearing 1/8 of an inch. So I'm just going to calculate that into how far my insert is. If you think of what I'm doing here is I'm going to insert onto this end plate, but I've got to make room for the ½ inch plate, seal plate that's going to be in there. So if I pick this, I'll show you what I'm going to do. If I say constrain, I can still use the insert command. I'm not going to pick I mean, this is the outermost landing where it will touch the seal plate, but really I'm going to insert from here. Any edge here that's it's like either this edge or this edge to me, or on the same plane. Yeah. So if I say insert this to this, well, that would be them like face to face, and I don't want that. I want at least a ½ inch, so I can add the ½ inch there. But I still need 1/8 of an inch more because the little feet are going to be a little bit, they're 1/8 of an inch past that. So I'm going to change this to 0.625. That's not a double point, but let's see, 0.625. So that will be a ½ inch between the feet and the end plate. So that's what that's going to be. I'm going to say okay, apply on that. And then I'm going to do a plane alignment there. And I'll keep my grease circ up in the 12 o'clock position, just like I did over here. That one doesn't quite look like a grease circ, like it's almost sealed, but you could put one in. This one looks like it comes with a grease circ. That's what you call that little thing, a grease circ. Zirc, I don't know why. Because we needed more Z terms in the dictionary. So yeah, this plane here, yeah, that plane, and then the plane on my bearing I should have a corresponding plane. That one, yes. It went the wrong way, I'll flip the solution. It's grease circ on top, so I'll apply that. See, yeah, it's like it kind of locks down. It saves you like the insert when you can use it just saves you like one more step because constraints usually are those, locking down those degrees of freedom essentially. And yeah, it's just that insert command does 2 in 1, two for the price of one. So that is ready. And then what I have is a model. So we've got to come back and I've got to like make a copy of that part, the seal plate, and I've got to modify it to fit this bearing. And so that's something you can do. It's like follow the same steps we used in how we made this one match that bearing. I'm gonna go in and probably just make a copy of this part. So I'll just talk through this real quick, but and I'm not gonna do this yet. I'm gonna do something else before towards the end because I'm about ready to wrap up actually. I just want to do I want to put the gearbox in here and take one look at it. But what I would do is make a copy of this part. And then, so I can do like a file save as, and I can plan this out right now. So I'll do this much of it where I know for my other side, this doesn't match. This was definitely built to match that other bearing, and we have a different bearing, different hole pattern, different size of holes. So I've got to just change this, but it's funny. I need all the same seals and everything on it. So a lot of this is going to be able to stay. It's just that the hole pattern, the overall profile is going to change. So I'm just going to make a file save as, save copy as. And I'm going to put this in my parts folder as my next part, which to me is like 24 for me, but and I'm just going to save that in there and leave it in there for a minute, and I'll just try to remember I did that because that part is now ready to modify. So I have this one, and then I have that other one, and then I will have to go to the assembly. Oh yeah, I did it. I just did it as another part. So I've made, yeah, so which one did I had this one, and I just did a file save copy as, and so I made a copy of this in my parts folder. And so I gave it a new name when I did that. So there's another seal plate in here right now that totally matches this, but I'm going to modify that to match the other side. Yeah, exactly. You just need the next part. It's going to be its own individual part because it's not going to have the same outer profile or the same mounting holes. This is all going to be able to stay the same. All the work we did for the machining is going to be the same. It's just that the overall profile, I think, has to go down in size or up in size. Can't remember. And the hole pattern is definitely a smaller hole pattern for this leather bearing. This is where it's not ideal because it would be nice if both seal plates on both ends were the same part. And so this is a design that can be, I mean, this is going to work because the engineers supplied us with those are the bearings we're using. So they've already kind of constrained us into using those, which makes me have to make two different seal plates. But this is a design we could revisit later and say, how can I find a bearing that would have, change out one of my bearings so I can have the same seal plate? That would be a great design change in the future. But right now, I'm just going to have separate individual ones. Um, so I've got that copy saved, and I'll go back in and modify it when I need it. And it'll need another assembly too, and I'll show you maybe a trick on that because I could. This is wherever there are. This is the part in an assembly. Um, I'll come and I'll revisit this too, but I can make a copy of this assembly and then swap out the part in it as well with the other part, and because it would be another unique assembly with a different part in here. And so really, I'm going to end up making a different part and a different assembly for these two end seal plates. But you can take an assembly that you have a part in and everything, and you can actually like manage. Let me see here. How would I do this? Let me remember. It might be just a right click menu. If I select this part, right click, component replace. This is something we haven't got into. It's another detail here. But when you're in an assembly, so I'll just talk through it. I'm not going to do it probably till tomorrow. But what I would do is I can make a copy of an assembly and then it doesn't have the right parts in it, but I want to put the right parts in, and they're really similar. And so in this case, they're, almost perfectly similar. But I can come in here and like right click a part in an assembly and bring up this component menu that has another expandable menu, a menu within a menu. This is really handy to replace. I can pick, so when I would pick replace, it would allow me to go to a part folder and pull out that other part that I maybe have modified after I got to do some changes to it. And then I can say open that and it'll swap those two parts out. And it will keep the constraints that it can, but if you've done a bunch of constraints from this part to the next one, it's definitely going to make you rework those constraints. And it's one reason why I try to minimize how many like part to part constraints I have, and I kind of maximize how many like just kind of like origin, constraints to parts, because those don't blow up when I do this kind of a little trick. And I do this a lot. There's a lot of similar assemblies. I just need to swap out parts. The other thing is when you do that kind of work, sometimes the model browser keeps the old name here and it has a hard time jogging on the new name. maybe if you close it, save it, open it. But sometimes these names are stubborn to change in your model browser for whatever reason. I think it's a bug with Inventor a little bit. But they do have this like on the uh, on the same tab on the same huge drop down of your ground and root function, there's a rename browser nodes. And I know I've talked to this a couple times, just repeating it. And I've talked to it individually with some people. But in the event that I do that replace within an assembly and I can't get these to load right, if you rename browser nodes, it'll almost and file name is the default, but you could choose other things to like force. What it's just doing is doing like a hard force to force those to take on their new file names. And that can be helpful because I use my assembly sometimes to identify what parts are in my assembly. And if they're mismarked over here, that really throws me for a loop because I'll like see a part number on my model browser. I'll open up that part and then it's a different number, part number that opens from what's on my, that's my indicator that, oh man, this like model browser in the assembly needs to be like jogged and accept its like browser names. And so this is it's I feel like they must have built this in at some point because they had this issue. And this tends to force that change. So you'll never remember this when you need to use it, but I'm just going to give it to you anyway. Because that is kind of a detailed little thing. Okay. All that talk about that, I could have done what I needed to do it, but I'm not going to. I'm actually going to go back to this real quick. Bear with me here. We're going to just get a little bit of a start on, I've got the bearing in, I've got it mocked up where it goes. So now I can kind of evaluate if this shaft is long enough for my gearbox. And so what I did is I loaded, I think I lost my, this one. I got to turn that one off. Oh yeah, yeah. I think what I loaded, let me go to Canvas real quick. It's my last thing I want to do. And then we can just push pause here for a minute. But if I go to my, oh, I thought I had, I do have, yeah, right here. I loaded up another file for you in the screw conveyor resources. Uh, screw conveyor resources. I loaded a part file in here, drive, gearbox, and motor model right here. And I was going to go through the process of like showing you how to pull one of these from a manufacturer's website. I don't think we're gonna have time for that. So I just loaded the gearbox. We can bring this in. It's going to be this big red part here. So if you want to, if you go to this, you can pull this in, download it. In fact, I'll download it right now while I'm in here, actually. So there's my download. I'm just going to move this to, I didn't toggle on where to save that out. So it's just in my downloads. Downloads. There's my Suyu. I'm gonna bring this to my part file. So I'll expand that out where I'm saving that stuff. It's my screw conveyor for 2026. I'm just going to drag and drop this. It doesn't have my exact, it's just a, this is a SU Euro drive, SEW Euro drive. It's actually European made. They assemble them in the United States too. They're really high quality gear motor. It's the gear motor because it's a gearbox and motor combination already like put together at a manufacturer. You can buy them separately too. You can buy your own gearbox and a different motor and make them fit. But this one is a conjoined, I guess, part here. So I'm just going to drag and drop this into my parts. And I have my SU gear motor. I'm going to place that in that assembly really quick. So this is my last little step. Back to this thing. Now that I've got that downloaded, I'm going to place it on here. So I'm going to go find it, place it in this assembly. There's my SU. I'm going to open that thing up. There it is. Pretty big honking thing. I can rotate it into position, right? That's just me. I hit G on the keyboard after I select an item. I can rotate that how I want it. And then I will just do an insert here. So generally there's a little space between here and how much like between the bearing and where the gearbox goes. I don't have an exact number in mind, but maybe an inch away from it right now, and I can kind of evaluate that. So I'm gonna do it. I'm just gonna do an insert on this. You'll notice this gearbox has a keyway, and so we'll talk about this tomorrow, but I just want to get it inserted on here and kind of take a look at it. And so I'm going to do my insert constraint one more time. And I'm looking for the outermost face of this gearbox, which is kind of this little collar that sticks out of it. So I could either pick here or here, an edge that goes with that face. There's that one. And then I'm going to insert it on. I'm going to pick, maybe I'll pick the bearing, or I could even pick the housing. I could pick something, and I've got to come up with an offset distance. If I just pick this right now, I don't love this because it's the bearing, but it's okay. I'm going to do it. So I'm going to pick either this outermost profile of the bearing, either the inner one or the outer one here. That'll slam those together. But generally, we like a space between these. And I don't think it's an exact, I don't think the gearbox information is going to tell me how far to space that off. But I would say not a ton, because it is kind of a dangerous little area. You wouldn't want to get something wrapped into this area. And so I might look up I'm going to put it an inch away right now. So that's an inch outside the bearing to where my gearbox gets inserted on that shaft. I think I have some problems with this model though, because that I might come in and check this model because it's really huge, right? Do I have this thing? Am I crazy? Yeah, I'm gonna keep it, but I may make us swap that out because I must have pulled, I must not have defined the, yeah, I think it's to scale. I think I just haven't, when I pulled the model, maybe I didn't set this should match that because you should be use their model to evaluate how it really fits on here. So I think I do need to upload a new model. I'll just go back in and check and pull a new part. Leave it in here because we can swap it out with the thing I just told you, the little replace model thing. So I'm going to say okay on this. And then I'm just going to the way the way there's a lot of different, so this thing is going to be like this. And when you choose a gearbox in this particular company, they want you to already know, they want you to tell them which way is the motor going to go because it's called like just the mounting configuration. So like right now, it feels like I could just rotate this anywhere I want, but as designed and it's supposed to be like at 12 o'clock like this, the motor above the gearbox. And and if I wanted to mount one like this, I need to tell the gearbox motor manufacturer that that's how I'm going to mount it. Because it might change their model that they give you or they would supply me. And it definitely changes kind of the oil level in these gearboxes depending on this. And even if I went down like this would be probably my least favorite way to put a gearbox. Usually you would see this combination being either kind of out this way, or vertical up and down. And this is a shaft mount gearbox, which means I mean, we could have a shaft that has like a bunch of gear and a chain going over to a gearbox. If you think of maybe things you've seen in farm, especially farm equipment, you see a lot of like gearing with chains, and then the gearbox sits over here, or some little support holds the gearbox, and then it has a gear on it, like a spur gear, and then there might be a gear that we would put on our shaft, and we would put a chain, and we have to guard it. In food processing, in fact, at Simplot, again, they made a standard that no gearboxes were chain driven, except for there was some that showed up. Of course, they have a standard, and then not all manufacturers followed it, but generally they wanted no chain driven gearboxes. They're just kind of dirty. They're kind of dangerous, and I mean they're usually guarded, so there's a safety component to a chain driven. Except for on the farm, they're not. They're really dangerous. Like farmers do think. I mean that's why I mean they get the job done minus a few fingers every once in a while. But gearbox, I mean, yeah, gear and chain drives are really dangerous. PTOs on tractor. Oh, gee. Anyway, I'm seeing like safety videos flying through my head now. Horrible videos. So, um, long story short is this is like a cleaner assembly. So some manufacturers like this. It's like the gearbox right on the shaft. It's like a shaft mount gearbox. And the standard was, at least in the processing area of Simplot, they had this as the standard. There were no chain driven gearboxes, chain and gear. So anyway, I just want to insert that on that, and I'm going to clock it at 12 o'clock. So I'm going to do, hopefully it's origin plane, that one there on that particular part. Well, let me just see. Where's my part? There's my gear motor. Let me collapse these real quick. There's my gear motor. So I'm looking for that plane of the gear motor to go to this origin right now. And then, oh yeah, I need to constrain that though. Yes, like that. This little bracket is to hold it, so it does need a mount here that's going to come like off of my conveyor to actually bolt on this thing just to help it stabilize it. Yeah, it's going to hold it. You need to almost have a force acting against the force that it's rotating. So you got to hold it. Otherwise that thing's just going to turn itself around this shaft. So we got to hold the gearbox stationary and spin the thing. So I don't have this part designed yet, but I've got to come. So we'll talk about that. That's kind of a tricky little thing. I might have to actually weld some stuff or bolt on something to my end plate to come out here and carry that. And they usually put about a pretty heavy plate, like 3/8 plate. all profiled up, contoured up to be able to reach out to this bolting location to bolt the gearbox on. So anyway, I'll just leave that on there. I'll take one look at it though. What we've got to address, and I'll finish this up probably on Thursday. If I just take a half section view of this, and maybe I'm going to cut through like right here. I'm just going to pick a plane that's this way to cut through and take a look at how the shaft meets the gearbox. This is my issue. That should be the same diameter. So I've got an issue. Uh, so I've just got to go in and pick a new model that has a 2-inch shaft. It also this wasn't was I, what I this is not what I was expecting to have here either. Although because what I was actually looking for is a torque lock type, which doesn't require a key. This particular model does have a key, and so I just and then the additional thing I need is I need a lot more shaft to carry this gearbox too. Like in this particular model might be like, well, how far do I go? It's got this pin, and I'm like, yeah, I wasn't expecting this to be in the model. I was hoping it would finish to a flat surface so that I could drive this shaft all the way into probably right here on the model. So I'll do a little model changing potentially, and we'll swap it out in our assembly. But what I need to, so I'm going to stop right here with today's work and leave you some time. And I might look at my 3D Derby car, but and I have some tools back here. I can kind of walk people through if they want to use any of the tools. But anyway, yes, this has got to be changed. I mean, I need a lot more shaft for a shaft mount gearbox. And they don't know that, when you come to this manual, they don't know exactly how. I mean, they give you this dimensioning stuff, but they don't know exactly what my application is. Well, my application is not just a gear sitting here, it's an entire gearbox on a shaft. So these variables don't become, they're not going to meet what I need, and I've got to make that fit. So yeah, this is a good place to stop. So I've got a seal plate to make, and then I've got the correct model gearbox to swap out, and then we got some hardware to add and some drawings to make for that. So yeah, we got work to do still.